Good day, my highly esteemed viewers. You are welcome back to class. As you still know, my name remains Israel. Please, if you have not been subscribing to this channel, or if you are not yet subscribed, kindly subscribe. Also, press the like button and help to share it. Today, we have selected some questions that will help us in this forthcoming Waec theory and also Neco theory. So, let's get started without wasting time. Selected questions for Waec and Neco. Define transition elements. As you know, they are the normal elements of the S&P block. For number 1, hydrogen with atomic number 1 to the one of calcium with atomic number 20. All those are referred to as S&P block elements. They are not transition metals or transition elements. As we leave number 20, which is calcium, the first one is scandium. Scandium to zinc. Those are the transition metals. Now, as the question requires from us, define transition elements. Transition elements are those elements that have their d orbital not completely filled. That is, in addition to the s and p orbitals which they also have additional one, which is the d orbital. And not just having the d orbital is partially filled or not completely filled. That is the definition of transition element or transition metal. That is the first one. Second one, explain the properties of transition elements. Now, we said transition elements are elements that have their d orbital not completely filled. Let me give an example first before I go to the explanation. Let's take the first element, scandium. Scandium. The symbol is Sc and atomic number is 21. Now, I want to write the electronic configuration of scandium. Sc, which is 21, is 1s2, 2s2, 2p6, 3s2, 3p6, 4, 3d1, 4s2. So let's count it. Always count it to ensure that they sum up to 21. 2 plus 2, 4, plus 2, 6, plus 6, 12, 18, 19, 20, 21. So this is the electronic configuration of scandium. But we are saying transition metals are those metals that have their d orbital not completely filled. This is the d orbital. Remember, the d orbital have 5 blocks. 1, 2, 3, 4, 5. You see it's just one because we have only one here. Therefore, the rest are not filled up. Therefore, it is a transition metal. If the rest are filled up in pairs, it's no more a transition metal. This one takes up the question of the day. Explain the properties of transition metals. You know already, we know the properties of metals. For example, they have high melting point and boiling point. They are good conductors of heat and electricity. They are ductile. They are also malleable. They are sonorous. That is, they produce a special pitch of sound. And so many others. Those are the properties of metals generally. But when they ask you, explain the properties of transition metal, those ones are not inclusive because those ones are the general properties of metals. For the transition element, because of the presence of d orbital, we give them a special property. We have just 5 properties. 5 properties. These are 1. Properties transition metals. You have the first one, variable oxidation state. So let's state it first before we explain. 2, they are paramagnetic. 3, they act as catalyst. 4, they form colored ions. 'Then the 5th one, they form complex ion. These are the 5 basic properties of transition metal, not the other one for metal generally. Because the transition metal are also metals, but this one, the presence of this d orbital make them have this special property, which is not present for the s and p block element. That's from hydrogen to calcium, atomic number 1 to atomic number 20. So, and we know that if transition metals, they are from the first transition metals actually, which is in your syllabus for O level, is from 21 to 30. Start with scandium, ends with zinc. So let's go to the question and explain properly. So explain the properties of transition metal. The first one, they have variable oxidation state, meaning that the oxidation state is not just one, it's more than one. Like iron has several oxidation number. That is, you can have iron 2 and iron 3. You see, depending on the compound it is combining with. For iron 2 chloride, you have iron 2. Iron 3 chloride, you have iron 3, Fe3 plus. That is, they have variable oxidation state. And it's common to all the transition metals. Then you have, they are paramagnetic. They are paramagnetic means they have unpaired electrons, which that makes them to be attracted to a magnetic field. They have unpaired electrons, like we just drew the diagram like this. Their electrons are not paired. If it is paired, it will be called diamagnetic. But this one have unpaired electron. These are paired, but they have only one. They must have one single one. One single one must be present, which make them paramagnetic. As a result, they can be attracted to a magnetic field. So they have magnetic property because of this. Then they act as catalyst. They act as catalyst by forming an unstable intermediate. They form unstable intermediates which have a very high energy and easily decompose into products, like vanadium. Vanadium can be used as a catalyst for so many reactions. That is an example of a transition metal. Vanadium can be used as catalyst. Iron also can be used as catalyst. Then you have, they form colored ions. Transition metal usually form colored ions. A good example we can take, we can also take the iron. Iron 2 is green in color. Then iron 3 is reddish brown. You see it? That's like rust. So they form colored ions. Copper 2 is blue in color. So that is also a member of the transition metal. Remember copper 2. I didn't say copper 1, copper 2. Then they form complex ion. A complex ion contains a charged group of atoms. A charged group of atoms. It usually have usually have a central atom attached to others we call ligands. For example, let's say we are using zinc hydroxide complex. Let me clean some part off. Let me clean this side since we already explained it. Let me clean the top part. This is ZnOH4 2-. You see, this is a complex ion. Zinc is taken here as a transition metal. You can also draw it like this. Zn, OH, 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 then 2-. You see, this central atom, which they may ask you in your objective, note it very well, is called central atom. All transition metals always have a central atom, and they are attached to other group we call ligands. All this other group, all this one, they are called ligands. So that is the explanation, brief and short, brief explanation of transition metals. So let's go to the next question. Next question says, write the electronic configuration of the elements scandium, chromium, copper, and zinc. We are told to write. While I'm writing, I will also explain it so that you know it in detail. Now, scandium is what we wrote before. This is 21, this is 24, this is 29, and this is 30. So scandium is 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. So you add it together, that gives 21. This is 10, 18, 19, 20, 20. So this is the electronic configuration of scandium using the SPDF notation, which they request from us using SPDF. They must specify it before you use it. And moreover, is the one you have to use anyway, because you cannot use that old method. The other type is the one of first 20 elements when you have 2, 8, 8, not that. Because you have transition metal, this is the only one applicable to it. That one is not applicable. So you have this. Then chromium, 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. Let's count it first. This 10, 21, 22, 23, 24. Some of you may be wondering, This is not the usual pattern. How come you are putting 5 here and this one is 1? Look at the explanation. Although the question does not require the explanation, but it's good for you to know it because of your objective. This, let's start from here. Let's assume this one is 18. Let's say argon 18. Then you have d orbital here. Let's remove this. This is d orbital. You have 3d, 1, 2, 3, 4. Then you have here 4s, like that. Now, supposed to be 1, 1, 2, 3, like this. 3d4, 4s2. That's how it's supposed to be under assumption. But you can look at it according to the principle of chemistry. Every element in the periodic table want to be stable. So if these blocks are singly occupied, there is a measurable amount of stability. We can say they are partially stable. The important thing is that they want to be stable. So if it's singly occupied or doubly occupied, they are stable. If it is doubly occupied, say 2, 2, 2, double spins, there is no more a transition metal. Because remember, by the definition, meaning is very, very stable then. So it's not a transition metal. Remember, by definition of transition element, there are those elements that have their d orbital partially filled. So for it to remain a transition element, it must have d orbital partially filled, not completely filled. So because if it's completely filled, it will be very, very stable. It's no more a transition metal. But if it is partially filled, it is partially stable. It is still stable a little, though not completely stable. So you can see, because in order for this element to attain partial stability, like now it's not stable at all, 1s we have to move from here to take this place, making 1, 2, 3, 4, 5, 3d5, 4s1. That's how it came about, and that is the accurate work. So that is why it is like that. So let's go to the next one. Copper. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. The same reason. You see it? The same reason. This is supposed to be 3d9, 4s2. In order for it to be stable, one electron moves from the 4s2 and goes to the 3d9, making 3d10. In which case, our diagram for 3d orbital 1, 2, 3, 4, 5 will now be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3d10. Then 4s2 that is supposed to be like this will now remain 1, because one electron will be promoted, have been moved, not promoted actually, have been moved to the 3d orbital, making it like this. In that reason, with that reasoning, this one is no more a transition metal, because it has the 3d orbital completely filled. Then zinc. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2. If you add them together, this is 10, 20, 30. So this is electronic configuration of zinc. Naturally, zinc is not a transition metal based on that definition, because it has 3d10. The d orbital is completely filled. Based on that logic, it is not a transition metal. So this is the structure of zinc. This is the electronic configuration of zinc, sorry. Then the last one is, why is zinc referred to as a transition element? You see it. We just said that based on this structure, zinc is not a transition metal. You see it. That is why zinc is not colored. Remember, transition metal have color. It doesn't fulfill the criteria of the properties of transition element. For example, the first one, we say they are paramagnetic. That is, they are attracted to a magnetic field. Zinc is not magnetic. We say they form colored ions. Zinc is colorless. We say they form, they are act as a catalyst. It doesn't work out. We say all the properties doesn't fulfill anyone. However, they said, why is zinc refers to as a transition element? Meaning, among the properties, there is still one property that makes it to be attracted, that makes it to be a transition metal. The only property is complex ion formation, which I just wrote. Zinc OH 2-. It is only this property that makes zinc a transition metal, because it can form a complex ion. This complex ion has a central atom attached to other group. You see it. So because of this complex ion formation, that is why it is regarded as a transition metal. The ions are not, they are not colored, so it doesn't fulfill all those ones. It's not attracted to a magnetic field and so many other. It doesn't have variable oxidation state. You only have oxidation state of 2 plus 2, and that is all. So, my dear viewers, thank you for watching my channel. Please remember, your Waec theory is still ahead. Apart from Waec, you still have Neco ahead. Kindly continue to watch. Remember, this is chemistry. It's not just it's not just the other kind of subject. To understand it very well, while you want to watch the video, kindly get your biro and pencil and make sure you jot down something. God bless you.